Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on statistical sampling techniques. Today, we are beginning a new unit in which you will learn how to construct and interpret a variety of statistical graphs. You will also study specific measurements that are used to analyze statistical data. We will start by examining various techniques that are used to collect samples of data. If you are ready, students, let us begin. Because statistics deals with the proper collection, organization, and analysis of data, it can have a great impact on decision making. One of the most important steps in statistical analysis is the collection of accurate data. Inaccurate data can lead to misleading conclusions and cause poor decisions to be made. In an ideal situation, data would be collected from an entire population. But this is often too costly or too impractical. Students, can you think of a way that investigators can gather meaningful information when it is impossible to collect data from an entire population? Please take a few minutes to write down your thoughts and then discuss them with a classmate.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. I am sure you had a productive discussion. One alternative solution, and the one we will be studying, is to take data from a sample. A sample is a limited number of items or people taken from a population. Sampling is the process in which a portion of the population is used to draw conclusions about the whole population. It is important to take a sample in such a way that it is a true representation. This requires proper sampling techniques. Such techniques will ensure that the sample is of an adequate size and that it is independent and unbiased. In this unit, we will study 3 techniques of random sampling. These techniques are simple random sampling, systematic sampling, and stratified sampling. Simple random sampling uses 2 methods to achieve completely random samples. The first method is the lottery method. An investigator prepares identical slips of paper and writes names or numbers for each member of the population on the slips. They are then randomly drawn from a container until the required sample size is reached. The second method is to use a table of random numbers. If you have a population of 40 students, each student is assigned a unique and consecutive number between 1 and 40. Then, a number is arbitrarily selected from the table of random numbers, and the last 2 digits are examined. If they are between 1 and 40, that number is selected as part of the sample. Let us say that we are looking for a sample of 5 students. On this table, we randomly selected this group of numbers. The first number of the group is 8, 3, 0, 2, 5. So the student with the number 25 is selected. We continue to select numbers moving down the column until our sample size is reached. The next sampling technique is called systematic sampling. This is another random sampling technique that assigns a unique number to the population, but it uses an equation to determine the sample. N stands for the size of the population, and small n stands for the size of the sample. K is the sampling interval, and we use the ratio population over sample to solve for K. We select a number between 1 and K. Starting with this number, the value of K is added in intervals to determine the next member of the sample. This sounds confusing, but it is really quite simple. If our population is 60 and our sample is 12, then our sampling interval, K, is 5. A random number between 1 and 5 might be 2. Beginning with 2, we add intervals of 5 until we reach our sample size. So, our sample includes 2, 7, 12, 17, 22, and so on. Stratified sampling is our last technique. This is useful when there is a categorical difference in the population. The population is then divided into homogeneous groups or strata, and a sample is selected from each strata by using one of the other techniques. For example, let us consider your school to be the population. You can divide the school into strata, such as grade levels or age groups. You then select a sample from each grade level or age group by using one of the random sampling techniques we just learned. Students, so far we have studied 3 sampling techniques. Can you think of their benefits and limitations? Please separate into groups of 3 or 4 and list some of the advantages and disadvantages of random sampling. You may begin now, students.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. Random sampling techniques are beneficial because they are free from any bias of the investigator. If done properly, the results are completely arbitrary, which means that they can give a good representation of the population. Random sampling has the advantage of being less costly than gathering data from an entire population. On the other hand, random sampling requires skill and experience to achieve proper results. As you saw in the lottery and random number table examples, it can require time to plan and carry out. It is sometimes inefficient because of the amount of time it takes to prepare. I hope that you enjoyed our first lesson on statistical sampling techniques. Next time, we will look at various ways to represent statistical data. Until next time, thank you, teacher. Thank you, students.